Welcome, everybody. I'm Charles LeBlanc. I'm with IMEG. I know a few of you here in the audience today. There's a few of you I don't. My apologies that I haven't met you yet. Today's actual presentation is focused on sensing beyond the perimeter. What we're going to be focusing on today is technologies that you can use to do protection of a site or facility in broad areas, various different detections. And I know probably most of you are like me, trying to keep up with this stuff, trying to understand it, and making sure it works well, and making sure we use it correctly is all a huge thing that we're always trying to do as designers, consultants, and when we work on specific applications. So we have a great group of panelists today. They're going to focus each on different technologies. So we'll let each one of them talk, but I'll introduce them real quick. First one is Kim Meyer. She's with Optex.
Happy to be here.
We have Aaron Sachs, who's training manager and product specialist with Hanwha to talk about, I didn't mention, that Kim's going to be talking about LIDAR. We have Aaron Sachs going to be talking about thermal technology, so with cameras and whatnot. And then we have Mike Stokes with Observation Without Limits, who's going to be talking about ground-based radar. So I'm going to let these folks talk.
Good morning, everybody. So I am Kim Meyer. I work for Optex, and this morning we're going to talk about LIDAR. LIDAR is an acronym for light detection and ranging. It works by using a class 1 laser head that emits laser beams out at a fast rotation, and that laser returns back to the sensor, which gives us the ability to calculate a object within the plane, size and distance from the laser. It is class 1, so I think I said that. It is class 1, so it is not visible or harmful to the naked eye. Historically, laser has been used to create mapping in geography and archaeology, as well as missile guidance. So, our particular system uses has a variety of different programming specs. Those programming specs allow you to adjust many facets of the laser to determine what you want to detect. So we have sensitivity, so we have low, medium, and high. It also gives you the ability to set up an offset around the detection area. We can detect objects as small as 0.4 of an inch all the way up to 32 feet. So very small objects being passed from one location to another all the way up to a truck. We have the ability to create masked areas that are not in the detection pattern, or we have the ability to create allocated areas. Those allocated areas can be divided within the plane to function differently and detect differently. Our LIDAR uses network or analog for relays for being able to alarm or alert that there was a detection. And in some cases, we can actually use those both IP and analog simultaneously. Our system also has an auto area adjust, which is used to reconfigure the laser plane for changing conditions, such as moved product within the plane or entered information left in the plane, and it'll recalculate and fill in areas. What are some of the pros for LIDAR? LIDAR gives you the exact XY coordinates, so it can be very precise whenever you're looking at an object. It also gives us the ability to interact with other systems such as video and provide that information and potentially send a PTZ camera to a precise location, which will give you that very specific video verification. The size algorithms for far and near distance, it interprets objects' size and distance. It gets the perspective right, so you don't look like you're looking at something very large because of an angle. The detection does require a clear line of sight, and the detection pattern is stable throughout the entire laser plane. So that's a key thing, that there is no degradation of the signal as it gets farther away from the detection. It's not affected by lighting or temperatures, so it can work in complete darkness. It gives us the ability to create virtual walls or virtual planes. It is a curtain detection in a 2D fashion. It gives us accurate detection for the far and near, and it can be used it can be used in environments, including in floor voids and false ceilings. On outdoor security, we have the ability to install it in a horizontal or a vertical fashion, and it gives us the ability to detect something as low as 10 inches in height, so someone crawling. Because the laser is also a very thin detection pattern, you can use it in close proximity to other devices such as fences, and it will allow you to still maintain your working area, but still give you that double knock of protection. So 2D LIDAR is used to create vertical laser walls and horizontal laser planes. It's perfect for applications such as above. Horizontal planes are perfect for flooding areas within a fence or a property, or rooftops. We're going to see rooftops here in just a bit. It is widely used indoors and outdoors. It is usually paired with video and acts as a trigger to record or enact a VMS. It can also be connected to the VMS as well as potentially a security type system. And there you can see it in the rooftop protection location as well as the sidewalls. These are more examples of it. So when we talk about case studies, we've deployed this in many areas, including this particular one is utility station fence lines. So these are remote areas, and they're very much unmanned locations in a lot of situations. So this gives us the ability to create triggers and events to notify someone that something is happening at those areas.
Excuse me?
Yes.
Are your triggers interpretive? In other words, does it say something this big crossed the plane?
It is interpretive by the way you have the detection settings set. So if I only wanted to detect a truck, someone driving up on a road, I would set my trigger to not detect something maybe less than 6 feet. So as a person, the laser would still see a person, but it wouldn't send an event.
I'm not sure that that's answering the question.
Okay.
So I'll give you a real logical
Sure.
example. So you're protecting a correctional facility.
Okay.
Where a lot of times they throw things over the fence yard where the folks are out supposedly recreating. And they recreate with the things that are thrown over the fence. Can you tell me something like a packet containing cocaine, marijuana, whatever, has been thrown over the fence?
Yes. Yes, and then that is done, and we do that. And that we do that in a couple of scenarios, and we'll kind of talk about that. And but it's based on the settings. So we would set that at a very low setting, and then that trigger would send it off.
So the question, just for record, is understanding just how sensitive and how controllable the technology is. And so it sounds like, to confirm, that the technology is something that we can actually adjust.
Yes.
And we can set it to do the types of detection we choose.
Yes.
Based on the specific application.
Yes, I'm sorry, and I know you told me.
You already put it in airports from secure side and not secure side of drug airports.
Yeah, and just to reiterate what he said, and that's also a person, that's Jeremy Hayes from my company. So we do that in airports today, where we actually have the ability to create a vertical wall, and we show that a passport is being thrown from one side of the secured location over to the unsecured side to be used again. Okay. Good question, though.
You have a question about it?
Oh, I'm sorry.
But that means anything bigger than a passport is also detected, so it's only to what you're, go ahead.
So it means that anything bigger than a passport is detected also. That's not exactly true. It has the ability, it's based on the settings again. So if I only want to detect something 1 inch by 4 inches, I set my settings that way. And then it will not detect something that's 12. It will detect it. It will not set off an alarm.
Understood. Thank you.
Sure. Anything else? Good. Okay, go on. Okay, so this is another case study that we have. This is a retail financial chain. And their challenge was that intruders were coming in through their roofs to actually steal money. So these were very unique areas in the fact that, one, they're outside, two, they have HVAC units and some obstacles within it. So we actually created a laser plane covering their roof, and this was done by putting 2 lasers on each side and completely flooding the area. And then we were able to detect when someone came into their roof coverage and before they actually were able to break in. And this has been done by having a setting of more than 12 inches, so that, and we also did it in a fashion that meant that it had to be within the plane for a certain amount of time. I think it was 5 seconds or 8 seconds or 10 seconds. Well, I'd have to go back to look at the exact settings, but because it wasn't just a presence, it was a time of that they were going to be in that plane. We were able to not detect birds and things that were coming in, because they come in and they usually go out. So we were not set to detect that, but then we did detect it whenever they were on there and they stayed up there long enough to set the event off. Okay. And this is done, this particular deployment has been done at several hundred locations, and we have less than a 2% false alarm rate. Again, in medical marijuana farms. So this is done both inside the actual grow rooms, as well as on the exterior perimeters. And we do this by creating virtual walls as well as planes in both locations. And depending on the type of regulations that they're being asked to adhere to, we've even done it to where we go down the rows of the actual marijuana plants to ensure that cross-pollination isn't occurring. So we set that at a very small rate, and it sets off the alert, and the alert goes to the caregivers to ensure that the plants are not being crossing the lanes. So indoor, outdoor, again, these are more case studies that we have, and I'd be more than happy to go over with any of these with you in depth on a one-on-one basis. What are the cons? LIDAR doesn't work well if you aim it towards the sun or at water. It will not classify the animal, or will not classify an object, so you can't determine if it's an animal or a human without, it's not a visual. So again, we have the ability to make those adjustments within the system, but it doesn't completely tell you the parts and pieces. And we also have to account for a shadow effect, meaning if it's not X-ray, so if you have something sitting within the plane, there's a shadow behind it, and most times that's easily done by being able to put two lasers pointing together. And it does need a clear line of sight. Oh, this is you. So, any other questions regarding laser right now? Okay. Yes.
One last one. Is there a particular limitation for indoor usage that you'd say in this scenario, stay away from using it indoors?
No. The question was, is there any scenario where you wouldn't, in an indoor setting where you wouldn't want to use this? No, I mean, nothing that's came to us at this point. We are a big company on doing proof of concept, that we know that this is still fairly new technology. So we look for, we want those challenges. We want you to bring those challenges to us. We want to work with you and your customers, and we want to be able to set it up as proof of concepts and make sure that we can actually do it.
What are your typical price points?
So our typical price points are anywhere from $1,400 to about $6,800, $7,400. And our largest laser covers it's a 5100, so 50 meters by 100 meters, so it covers 165 feet by 330 feet. I think you were first. Yes.
Any challenges with outdoor conditions like snow, fog, rain, that kind of thing?
It does. Any challenges outdoor regarding environmental conditions? Our system has an environmental disqualification alert. So if it gets super foggy or something occurs that it loses that connectivity, it does send in it is a supervisory alert to you. It is not super sensitive to that. So it's much better than active infrared or passive infrared.
Okay, thank you.
So I'll tell you what, we've got to get through two other technologies. Let's go ahead and move on to those technologies. Let's save any further questions, hold on to them. We'll pick them up at the end of the presentation today. So I want to make sure we get everything in front of everybody, because frankly, I want to learn about this stuff myself too. So
again, Aaron with Hanwha. We can talk about thermal cameras. So briefly, thermal camera technology is regulated here in the U.S. By the Department of Commerce. They cannot be exported outside the country without a license. There's some paperwork in terms of where it gets shipped to, who it gets shipped to. There's not background checks, but there's some paperwork that has to be done for that. We are now selling in Canada as well. I believe some of Latin America, but again, there are some restrictions with that, so just be aware of that. We can go to the next, thank you. Briefly, just so everyone knows who Hanwha is, we're a global Fortune 500 company based in South Korea. We value our supply chain of trust for cybersecurity. We have manufacturing facilities in South Korea and Vietnam, so we're TAA compliant. Our entire lineup now is pretty much all NDAA compliant as well. We've replaced a couple products in the past year or so, just to change out a chipset here or there. And that's all. We used to be Samsung. Some people still refer to us as Samsung. The Samsung security surveillance products was a division called the Samsung Techwin. We got purchased by Hanwha Techwin, or by Hanwha. Hanwha is just another South Korean conglomerate that no one's heard of in the US, but go figure. Okay. So what is a thermal camera? So obviously everyone's familiar with video and regular camera technology. There's a lot of misconception from TV and movies and CSI of what a thermal camera can do. We've also seen a lot of iPhones and things have thermal camera add-ons. That's consumer stuff. This is completely different. So what a thermal camera does is it sees, obviously, temperatures. So any object emits electromagnetic radiation, depending on the temperature of it. As the molecules are vibrating, you'll see the little picture on the bottom, a hot cup, the molecules are vibrating faster, a colder object, they're vibrating slower. So there's thermal radiation coming off of that. Any object that's above absolute zero, so anything you're going to work with, will be giving off this thermal radiation. So they're emitted from these devices, and just like we can see visible light with our eyes and with cameras, the thermal camera has a special sensor, special lens technology that's able to see that. Part of the reason why thermal cameras traditionally are very expensive is you can't use standard glass. Glass will reflect, so you have to use either germanium or sapphire lenses for that. Different parts of the electromagnetic spectrum, just like when you have a really hot object, right, your stove is glowing red, same thing here. So we're able to just to convert that to a visual. And so this is a school doing a proof of concept. They wanted to know for active shooters. And I'm fast forwarding and rewinding, so that's why it's going quickly. On the left is a visible camera, on the right is a thermal. Obviously, the different field of view for each one, just because of this demo here. But they filled the room with smoke, and they wanted to see, could they use the thermal camera to see through it so active responders can still be able to respond. And so you can see the room is completely filled on the left. On the right, we're still able to see it. We can detect, that's a person, get a reasonable likeness of them. I'll talk more about that in a minute. We can go to next. So applications. Thermal cameras are typically to provide high contrast, is to see something that might be blending into the background. So things like camouflage, complete darkness without needing IR, without needing to worry about lighting up the scene. Fog, snow, smoke, smog, any of that, it can see through it. And the key applications, key verticals are things like critical infrastructure, dams, ports, bridges, tunnels, manufacturing facilities where they have high security, obviously government facilities, things like that, and obviously border patrol or border control. Hanwha, and back in the day Samsung, we actually had some analog thermal cameras as well. So we've been doing this for many, many years, and border patrol, that's been a very active one there. Being able to see, is that a person, is that a vehicle coming? It provides long-range detection. We'll talk about that in a minute in any weather condition. And we do have a variety of video analytics. And you can also use it with things like PTZ handover. You can have a thermal camera detecting, hey, there's a hot object that shouldn't be there. Have a PTZ swing by and zoom in to give better video verification. And here's just a couple examples of some of the critical infrastructure or utilities. So you can see daytime, it looks like a wind turbine. Nighttime, you can't see anything. And something like this, really high, really tall, it'll be really hard to light that up with IR. And so a variety of different lenses on different models to be able to zoom in and be able to see what's going on, make sure the turbine is still spinning. A lot of applications, people want to know, is my facility still operating? Is it still spinning? Because it's all money for them, right? Is it still spinning? Are they getting the revenue in? Or is something malfunctioning? Okay. And here's a port example. Right, they want to make sure, is the channel clear? Are the boats unloading? Are the cranes operating? Maritime safety, things like that. So certain places, like in California, where it gets really foggy, San Francisco, they need thermal cameras to be able to make sure, again, for port safety. So it's a great solution there. There are different color palettes that you can adjust. So depending on what you're looking for, it's a setting in the camera of to help with the contrast of trying to see what you're trying to see. You can choose these built-in pre-configured ones. There also is a custom one where you can give it a temperature range that you're interested in, and everything else will be in a background color. So you can really target. I'm trying to see a person, a hot vehicle, whatever it might be, and you can really target that. So in terms of detection ranges, we have different lenses, just like a normal camera has different lenses. So this is our biggest lens, so this is our maximum range, but we do have other lenses for a variety of other applications. The largest lens we have today is a 35 millimeter lens that can do detecting a vehicle at 10,000 feet. Now what that means is in terms of things like dory detection, right? So I'm detecting a 7.5 foot tall object. It doesn't mean my analytics is detecting it. It means that that there's enough pixels to detect something that's big, that big, and a hot object. Now, obviously, I will talk about some challenges. If a car is really cold, if it just got started up, it might not be able to see it because it's too cold. And then same thing for a person that's a little bit shorter, about 4,000 foot detection. We can get better recognition and identification, obviously, at closer distances. Again, there's going to be a limit to how much we can recognize or identify a person because thermal cameras are typically lower resolution. I think this is on the future slide, but our thermal cameras we have today are VGA resolution or QVGA, so 640 by 480 or 320 by 240. Right, so our product lineup, we've got a range of 16 different models today, like I just said, the resolutions. The standard form factor is a bullet. There also is a PT head to put it on an existing pan tilt driver. We do have a look up pan tilt module. We also have a bispectrum camera that has a visible head and a thermal head, so that's really, really popular, so that way you get the benefits of both. We also have what's called a radiometric. It doesn't really apply for perimeter control. Radiometric gives you the ability to not just detect that, hey, there's a warm object, and our standard thermal, you can set an analytic to say, hey, if something gets too hot in this zone too quickly, let me know, and that's an analytic. With a radiometric, you can set a specific temperature. So that's usually more for industrial applications, that I want to know if this transformer gets too hot before it blows up, because that transformer is hundreds of thousands of dollars and there's lead time and now everyone's out of power. So we do have radiometric for much more specific use cases. The video streams in H.260, oops, that's a typo, H.264 or H.265 or motion JPEG. And then, like I said, we have a variety of our normal analytics. Obviously, your resolution is lower, so your analytics needs a certain number of pixels, and that'll be a little bit more challenging. But we, again, do have the temperature detection analytic, and I mentioned PTZ handover. And then I think my last slide is, two more slides. Limitations. Things like mirrors, just like a mirror will reflect light, a mirror will reflect a thermal camera as well. So mirrors or shiny objects can cause issues. So you might have seen in movies, someone might wear a shiny suit to try to get by it. That could be done in theory. If an object of a person is the same temperature as the surrounding, you can somewhat blend in. Obviously, a person isn't one uniform temperature, but if something has similar background temperature, it could kind of be difficult to distinguish it. About every 3 minutes, there's something called the NUC. It's an internal way that the thermal camera works. So about every 3 minutes, you might lose one frame where the video will stutter for one frame. Not really a big deal. And I mentioned the last bullet. And then my last slide is costs. US MSRP, they range from about $4,000 to $16,000. Obviously, the $16,000 is the big PTRZ, the big PTZ motorized head. But the prices will vary based on if it's a VGA or QVGA. That's really the bigger part there. The radiometric has an increased price as well because the sensor is even more sensitive from there. There's a lot of factors. If you look at the data sheet of a thermal camera, and that's where it really varies from the cheap consumer things you'll see at Home Depot for $200 or whatever. Just like a normal camera, the sensitivity, the amount of noise it'll generate are completely different than what we're dealing with here. Any questions? Yes?
Can your AI be used for standoff weapons detection?
So the question was, can AI be used for things like weapon systems? So Hanwha has another division, and so did Samsung, of weapons and tanks and whatnot. So there are...
weapons detection.
Oh, weapons detection. So I thought you meant arming a... Got it.
I've got a gun.
So not easily, because typically most weapons are either, they're not going to have a huge, like if you have a gun on you, it's going to warm up to your body. So typically not. It's also going to be covered by something. There are AI systems that are doing that using a variety of technologies, but typically thermal is not going to be used for that. Yes?
Yeah, I've wondered, in the world of 4K and 8K cameras that we have now, why are thermal cameras still on the 320 by 240 range?
Yeah, so the question was about resolutions. In standard visible, we're going 4K, 8K, and thermals are low resolution. It also has to do with cost. The sensors are really expensive. as well as the lensing. Traditionally, for many years, 320 by 240 was the standard, and then the past, 5 years, they've increased their VGA resolution. It also has to do with there's cooled sensors and passive sensors. When you start getting to too high of a resolution, they generate more heat, and if the sensor generates heat, that's going to mess up the detection, and so it needs to be an active cooled device, which all of a sudden now it's huge and the price skyrockets. Military type of technology. So will it get there? Possibly, but it's just the limits of the price points for this market application. And then also typically detecting a vehicle, it's going to be hot enough. I don't need all those extra pixels for that. Yep.
And you mentioned that thermal cameras are really working by looking at temperature differences. So in the daytime, do they perform, is there a limit to how well they perform in terms of human beings relative to?
Yeah, good question. The question was about if thermal cameras work by detecting temperature differences, is there a problem during the daytime? Typically not. So even if you go to a desert, right, the desert's going to heat up during the daytime and be scorching hot. Typically, a human body temperature is still going to be different. A vehicle is still going to be different than that background. What's going to happen is some of those sample pictures you saw there, the color palettes will change. And so during the day, I might be looking for people that are a certain grouping of colors, and the background is a different set, whereas during the day, that background color might be different. So the operator needs to be trained and needs to know what the images look like and how to adapt with that. And that also will be tuning what color palette to use. But thermal cameras can absolutely be used 24/7, day or night, in pretty much any environment, whether it's the Arctic or desert, because you're still going to have that gradient. Yep. Any other questions?
We're going to move on for now. Thanks, Aaron.
Okay, thank you. We'll have time, hopefully.
Let's bring, we got some time.
You got two questions you got to hold, right?
I'm not going to ask you.
I only have 5 slides, so ask away. It's going to be easy. Talking about ground-based radar, we'll go through this pretty quick. So a lot of folks have not applied ground-based radar to critical infrastructure protection and security. So these are primarily outdoor sensors, unlike a couple of other technologies you've seen this morning. We basically irradiate radio frequency energy into an area and sample it back digitally and take and measure information about the object. We get, the location, the range, the angle. We get that word Doppler up there is a fancy name we get all kinds of fancy information about the target. We can actually tell human beings from animals by counting legs and seeing torso shift. We can detect vehicles and classify them relative to boats. Of course, human beings, right, and even aircraft for counter-unmanned air system defense and so forth, or airspace deconfliction around airports. So these are the systems that we service the industry with. Is 4 products. They're not directionally scanning. So some technologies, think of the lighthouse, right? You have a sensor that's spinning, or even internally with a flat panel, you're directing energy in one location at a time. We actually irradiate the entire field of view and just determine how many times to sample it digitally. So update rates anywhere from 4 to 10 or 12 times a second. So a lot of information real quick. Our company services all 16 of the DHS commercial critical infrastructure sectors all over the world. We have hundreds of these all over the place. So these sensors are really designed to provide almost an integrated overwatch capability at a site. And then how much you choose to integrate other things with our sensors really depends a lot on the site, right? To deal with some of the challenges these guys have mentioned with line of sight limitations, complexity, and so forth. Similar to other technologies, you can define zones. Since our sensor knows where everything is at, knows which way it's going, and knows what it is, you can define zones to, hey, I only care about if humans come into this area, or maybe a no loiter zone. We service a lot of sites that have a lot of foot traffic next to them. They're extra roadways, railways. So you expect traffic to go by. You just don't want it to ever stop and linger, right? Or you want to know about that. So most of the time, these systems are integrated with a VMS or PSIM, Perimeter Security Information Management software, Milestone, Genetec, Tyco Secure, pick the flavor of the day, to provide an event-based basically model to the security operator. So instead of the model of what we call kind of persistent surveillance, where you have guys trying to watch a bunch of screens simultaneously and figure out what's going on, trying to get them to a model, and most of our customers do this, where they're literally looking at a black screen. And when an event happens that matches the criteria and the location they care about, the threats, something they care about, it actually pulls up the screen, has our radar display. We know where the object is. We know what camera can see it best, so it goes ahead and commands that camera and continues to command it to follow the object. We pull up procedures to tell the operator for that particular site, what sheriff department to call. Is there anything special about it from a chemical standpoint or related safety that they would need to know when responding? Those kind of things. And while the security guys are taking a response, our systems also coordinate a deterrence effort. So we'll turn on sirens, turn on lights, play audible messages. We'll even oftentimes give the security operator two-way voice back to the site, so we can tell the intruder, hey, you're being monitored, you got in the red shirt, get out of here, that kind of thing. And then in the bottom left, just some examples of the far right is one of our radar products. At the top, it looks like a little boot box, the white thing. Here we're integrated into actually a dual-headed, this is an ambient light and infrared camera. Then in the middle you see the little dome camera. When you have shadowing, as Kim mentioned, or these situations where these sites weren't designed for security, right? So there's buildings that are blocking the perimeter in place and so forth. We'll drop a little dome camera in there and integrate with it too. So if something goes behind there, we'll pull in that information and look at it. And then all kinds of lighting systems, infrared, standard, visible, etc. So I won't brief all these, but obviously, so our systems range anywhere from, detecting, from me to this gentleman here to out to literally 10 to 15 kilometers for vehicles, depending upon the size of the site. We have customers that have everything from small transmission distribution sites that measure a couple of 100 feet, 300 feet on the side, to airport customers that have 55 square miles interior to their perimeter, over 30 miles of linear perimeter fence they have to monitor. Situations where, if you were to try and physically mount cameras or basically any other technology that you had to get data and power to cover that much area, it just becomes, really undoable. So anytime you have a site you got to monitor all the time, you need some situation awareness. Most of our customers take advantage of the overwatch element we actually monitor the interior of the perimeter edge, and the property outside it. So even if they don't own it, they know that if someone's coming at them and chooses to stop and linger or whatever, the security officers can be made aware of that. And then we tailor the layered approach to match the response. So maybe if it's an external target not on your property that lingers, you want to tell the supervisor about it, but you're not calling the police just yet, right? If it is on the perimeter and attempts to get in or certainly gets inside, then you're letting everybody know. So those situations where you need situation awareness, a more nuanced response, you need a lot of information about the target, and you need to integrate with a lot of other capabilities to backstop their weaknesses, right? Because all of our technologies, if you had 10 guys up here talking about different technologies, they all have things they do great and things they don't do great at, right? Next slide. Poorly suited, so we've all said line of sight, you got shadowing issues, right? So if you're in the middle of a wilderness with a bunch of trees, that's going to be a problem. So you need to at least be able to see most of the perimeter or most of the area that you care about looking at. Areas where you have really poorly defined perimeters, right? So think of a downtown hospital where you can't tell the good guys from the bad guys. There's a bajillion people walking around, and we can't tell, unfortunately yet, criminal intent yet. This is not Minority Report, unfortunately, but maybe one day. So that's another problem where, another continually open gate. One of our large customers is a shipping company and have issues where they have a gate where they want trucks to come and go all the time, but they don't want anybody just to be able to pull in off the street. Well, then we pair with a technology we can put on a mobile phone or in the vehicle, so a cleared person can come in and out of there, but if a vehicle or an individual that's not cleared, we alarm on them. Go ahead. And as I promised my last slide, so, we all have to be physically mounted, we all need power and data. The good thing is, it only takes about half a day to install these systems. I don't know if you arranged our order in order of slide number or cost, but so that number obviously looks big.
I didn't. Yeah, I didn't arrange this.
I cannot
be accused of anything.
Okay. So you look at that number, and go, oh my God, it's $70,000. So, and I don't know how much apples and oranges we have here. Those are for our base systems that get out to about anywhere from 0 to, hundreds of meters. And it's all in. It's installation, it's the infrastructure, it's the computing, it's all that stuff, and a year's support and service and warranty replacement within 72 hours anywhere in the continental U.S. So I think I made up a couple minutes.
I think you did.
That was my last slide. Any questions, or I probably didn't give you guys time to interrupt, so.
So now let's go back and fill in the questions that we had earlier and pick up any more. This is a great time to do it. Again, and the questions throughout have been great. I mean, that's the whole purpose of this. And I kind of anticipated, I think I told all of you that I was anticipating lots of questions, and that's why I was a little bit worried about in this session. So if there's any other questions, please ask. Yes, sir.
Yeah, so on the radar, an application for like corrections, looking from the inside of the property out.
Yeah, so.
Just like somebody said before, somebody throwing something over the fence.
Absolutely. So the question was about application in the corrections environment. I was actually thinking you, sir, when I sat down, I meant to mention that. So we have customers today in the Southeast, Midwest, and even on the West Coast in corrections environments, particularly for contraband mitigation. So we deploy internal to their site in a secure location, take advantage of their building, their infrastructure, or whatever, power and data, and then look outside. Couple challenges real quickly. Most of it's turned into drone drops. Unfortunately. So we also integrate with RF sensors to not only we detect the drone and we detect the individual controlling the drone, but to even give them a line back to, okay, where's it being controlled from, right, offset. That's especially important when many times the operators are stood off a long distance from the perimeter, might not even be on the prison property. So yeah, we're working with several corrections departments there. Thanks. You're welcome.
I know there were questions lingering, so this is a great time. Any others?
So on, for the OWL, are all your sensors kind of a 360, not just like a single teardrop array?
No, that's a great question, and I, for time's sake, didn't say that. 2 of our sensors are 360. We have a small one that's perimeter, that's ground only, and we have a larger one that's ground and air. Then we have 2 of the same variants in a panel that are 120-degree field of view, and they're designed for when you need 4 clicks or higher. We have one that goes out to about 4.5, 5 kilometers. Another one goes out to, like I said, about 15. We often integrate and install them in a 360-degree configuration at large sites, but yeah, they're kind of tailored, as you might imagine.
Power requirements?
So actually, both for power, that's a great question. The question was about power requirements. I'll answer data also. So even our highest power sensors that get out 15 kilometers only pull a couple hundred watts. The small ones, matter of fact, the other 3 in the product family can all be solar operated. They're very low amperage draws. Our bandwidth is normally not the issue. We take up very little. Matter of fact, many of our customers use a cellular connection for our stuff, a wireless connection that's either secured or secure wired products like Redwin or others. As my colleague here with cameras shows you, when you start pushing around a whole bunch of cameras with high def, that's when you got to think about the pipe, right? So power requirements not so much, but you got to pay a lot of attention to the network topography.
Wow, okay. One more.
On the laser system, what is the requirement on the back end to identify and to set it up? Is there software and does it integrate with any of the systems, like for alarm monitoring, access control, whatever?
Good question. So the question was regarding the laser technology and integration and setup. So Optex does require certification for you to install these. All right, it's a free certification. It's an online certification, and we want you to certify as many people within the organization as possible. But the software, there is a software-based version, which is our Redscape Mini, and we've done that for a couple of reasons, because there are still some government entities that don't want to have an open platform, meaning with a thin client. Our new Pro models are all thin client, so you simply just open a web browser and all of the configuration is within there. The certification is required because there are so many variables that you need to set, and we want you to at least be able to, when you talk to our tech support, that you at least know where to go to make those changes. So it's fairly simple. Does that answer? I'm sorry, does that answer?
I mean, do you have an integration with any of the systems right now?
As far as fully integrated with Milestone and Genetech, fully. And Milestone probably even a little more than Genetech in the way that it actually functions within their program. We are open platform, as you know, so we're always looking for those other partners. But we also do IP and data transmission as well as analog. So from working with a intrusion system, it's very simple.
So the output of the detector itself has to go through the software, or is there actually dry contact as well?
Yes, on the back of all of our minis have 3 outputs and 1 input. And on our pros models, we have 6. Normally open, normally closed, dry outputs, and 1 input. So we do have the input for integration, like with an access control. For instance, if you want to be able to turn it off if someone enters an area that you don't want to set up an alert. Does that answer it?
Thank you.
Yes, great. I saw you, Miss Milestone. So she was like, yes, we do. So, okay.
Another Optex question. What about the lifespan of your device? Do the lasers ever, have a certain lifespan?
Yes. So the question was about the lifespan of a laser. So historically, because it is a laser, a moving laser plane going through a lens, the lifespan was diminished, and it usually was somewhere in the neighborhood of about 7 years. We have increased that now to somewhere near 10 to 15 because we have the ability to change the lenses. So that has been an improvement that our engineering group has made recently. So, when you look at an investment, which technology changes so rapidly in our world anyway, most of the time you're going to have something new within 10 years.
Is it a PoE device?
The question is it a PoE device? And yes, they are PoE. They do run on PoE plus.
Okay, so, but if you need the dry contact, you need to run separate
cables. Yes. It can run on an actual a power supply as well. So it's either or. We do run them in solar. We do run them on solar in some situations. So we're doing a bunch of testing with that as well. Is that it? Okay.
I got a question for Aaron.
Yep.
On thermal cameras, what other applications do you see security cameras being used for non-security applications, I guess,
Yeah, so...
And there's the right way to go with security cameras or commercial type cameras that do the same thermal functions?
Let me make sure I'm understanding. You're asking, are there other applications besides just security or besides just perimeter?
Just
or both?
Besides security.
Okay. So obviously this past year or two, we've seen a huge uptick with COVID. Whether that was done well or not, there was a lot of low-cost products coming out to detect a fever, but they were very low-cost and not precise. I mentioned about our radiometric product. So, right, the radiometric can detect a specific temperature. So we actually came out with our bispectral camera that had a visible to be able to identify if he's wearing a blue shirt. And it had AI to be able to detect the right part of the face and where the best place to detect the temperature is. So things like that, healthcare, we're going to see a lot more of that. Other use cases, again, specifically for the radiometric side, is industrial controls, critical infrastructure, detecting a power substation of, if that transformer blows, there aren't any replacements on the entire coast. It's going to take weeks to get a new one built and shipped. We want to detect it before it pops. Dams, detecting leaks, detecting anything strange happening. You'll see mining has used thermal cameras for a long time. They'll have battery packs for the miners for their lanterns, for whatever. And those battery packs, when they start to go bad, they heat up quickly, and so they'll have thermal cameras to detect them for safety. So airports use them for anything and everything. So there's a lot of applications for them. It's when I want to detect an unusual situation. Again, a lot of your traditional security, they're just usually priced out of it. But we're seeing a lot, especially now, the past 2 years, a lot of innovation in bringing prices down and bringing thermal cameras in more applications by bringing the price points down.
We pull at that thread just a little bit more on the health screening, because I know there are a lot of solutions out there and a lot of people have been interested in that. And I think a lot of it is sort of low cost things coming in that don't necessarily work well. Can you just talk a little bit about best practices and maybe some precision versus accuracy and using like black bodies for...
Sure. So the question is about the healthcare, temperature screening, and all of that. Obviously, I've got a whole slide deck that I don't have right here on that. There absolutely are best practices. The best practice is to follow FDA recommendations for the US. There also are some international guidelines. I forgot, IEC, whatever. But it really has to do with the installation environment. They don't want bright glass behind you. They don't want doors open and the cold air behind you, because that's going to throw it off. Well, the problem is when you walk into a building, that's usually what's right behind you. So, if it's really important to actually get accurate, reliable screening, like you said, you have to follow the guidelines in terms of the queuing, in terms of, did someone just run in from outside and now they're sweating and their temperature is going to be higher. And then the other piece is the camera actually a radiometric camera that has the accuracy and precision to detect that minute temperature differentiation, and how is it looking? Is it just looking for anywhere on the head, the hottest temperature? That's usually not good enough. It usually needs to be the tear duct, I forgot the name, the canthus, inner canthus, that's where it's supposed to detect. Some cameras have a equalization algorithm that tries to compensate, and well, that can cause problems. So, are you using AI to detect a person? Is there a visible camera to help it? There's a lot of pieces to it, and I'm happy to share. We actually did a webinar, it's on our website, that went through a lot of the details of that. I would say there's been more bad temperature screenings than good ones. And a lot of the ones that were touted by big manufacturers ended up being pulled because they didn't follow anyone's guidelines, and they just threw them. School systems wanted to, oh, we're doing something. We're going to spend $1 million. We're doing something. Did you actually detect anyone? Well, no. So, because they weren't following guidelines. So there absolutely are a lot of guidelines. But just like anything else, we have to design it and then implement it, deploy it, test it. And then also, it's usually temperature screening. You usually have a backup. If it detects an alarm, right, do you have an FDA-registered thermometer to actually test it? Has someone been trained? Do they know how to actually use that device? Or just go through, it's fine. You go to a concert and the thing beeps, just go through, right? Like, there's only so much you can, only so much you can fix. Hopefully that answered some of that.
I have another question, kind of back on the industrial applications. Have you guys ever used your thermal cameras for, we have a client and they do a lot of wood chip processing for like fire detection?
So the question was things like smoke or fire detection. Yes, often the issue is that fire is often, they can be smoldering or quick growing. But you'll typically have spikes and stuff. So a traditional thermal camera, my standard lineup, detects changes over time, over the course of a couple minutes. So that wouldn't really be good enough. So a radiometric absolutely could. The question is your sizes. Is it your minimum, your maximum? There are a lot of, we do have our open platform where you can load third-party apps, and people have done that. And especially when you pair that either with a visible or a bispectrum to look for the smoke, the haze. There are a lot of third-party providers that do that want the thermal in addition to detect there's something behind the walls or the ceiling that's combusting and the temperatures are rising. So it absolutely can be done. I think with AI coming out more and more, so the future, besides lower cost and smaller cameras, I think we'll be adding AI to look for things like that.
Have the cameras had to be UL listed as a fire alarm device?
So, right, so since our camera isn't doing that today, that's not what it's targeted for. We are UL, obviously UL listed. Right, they potentially might have to for that. I know for some of the third-party apps, they are in software that's added to it. It's still a video surveillance. Yep.
Thank you.
Well, just as anticipated with this group, I kind of anticipated that they would be going way beyond the general application. So, as usual, you came through. So, I think the biggest, I think we've got a little bit more time. If there's any other questions, we want to make sure that we get them all answered. I had a little bit more broad one that I wanted to bring up, but I'm not going to bring it up unless
I'll ask
we run
one on
out of
radar.
time.
So you mentioned that you guys can also classify objects. What are the objects you can classify with radar? Because I know the models typically are videos. I'm assuming you guys built your own models to go there.
Actually, no. Well, not really a model. So it differs from video analytics is we don't train the system. So we can detect the difference between humans, animals, vehicles, and aircraft. So we are looking for specific physical properties that we can observe that are common to all of the objects we might observe in those groups. So if you see a different vehicle versus another size vehicle, it's still going to look to us like a vehicle, right? For example, if you see one UAV versus another, it's not going to matter. We're looking at actually the microdoppler of the blade spinning and other heuristics about how it looks in radar space, right? In the spectrum.
Rules, you have some rules.
Correct, that's right, yeah.
Question for Mike real quick.
Sure.
As far as your radar, when it detects an object and you have it tied to a PTZ camera, for example, are you giving a PTZ the information to track that object? Is that coming from your software or is that some other?
Yeah, so the question was, what do we do when we command a camera, right, in response to an event? We're actually sending commands directly to the camera via OnVIF. There are a couple of, I can think of customers who, they use video management systems that they prefer us to do it differently.
Yeah.
But by and large, we're commanding the camera directly.
So if you have, for example, a vehicle drive up to like a substation and 5 people get out and go 5 different directions, is there a priority of which person what object you're going to track with that camera, or does it switch between objects? I mean, how does that?
It's completely dependent on the customer, what they would prefer. So we control the focal length and zoom and all that to make sure they're seeing the whole event. Then they have to tell us when we initially set up the system, do you want us to break away from the first threat and follow the latest threat? Do you want us to command a secondary camera, right, to pick up that second threat? But we can do all those things and do. We have a joke when you've been to one customer site, you've been to one customer site, right? So whatever they tell us to do, that's what we do.
So one thing, Mike, that I haven't heard, but I did get it, I heard it from Kim's side, is the integration side. I think that's an important piece, especially for yours. I think more people, and Aaron, you may want to chime in on that as well, just to make sure that everybody's clear on how you do the integration pieces.
Sure. So everybody throws around open architecture. We multicast all the data that we collect, measure, and have it do anything with out on the network to be consumed by any other security product or VMS or PSIM out there. Occasionally we will get but not occasionally. Most of the time, our customers desire a deeper level of integration. So we generally support dry contact integration, what we call, black interface, where they're just consuming some of our data and they're doing anything with it. So we're talking to them, but it's pretty much a one-way conversation, all the way to a deeper API-based integration, where actually the system's pulling data as it wants out of us. It's asking for information. It's telling us to do things. Milestone, Genetech, like I said, all more so than I can count today. So typically what happens is we work with a reseller or an end customer. We provide them a design pattern saying, here's what we do today, pick one off the menu. And then we either hand them the integration to do that and they put it in their system, or they ask us to write something specific. Those take literally a couple of days. They're included in the price. We don't even charge for them. And most of the time we learn that. We do free POCs and demos all over the US and internationally, so most of the time we suss all that out when we show up and do the demo for the customer.
And I just remembered, I forgot to mention earlier, you were asking about best practices for the temperature screening. Yes, black body is always recommended for that. Integration with our camera, since it's video, it's simple. You know, we have our own API that is integrated to all the big VMSs. We obviously have OnVIF. We use the OnVIF metadata service so that you can get events so well integrated at VMSs, milestone, Genetec, and so on. They'll get our temperature detection event. They can also get the alert of which zone it is. Zone A had an event. Our radiometric, they can also receive the temperature reading of, hey, that's 98.6 in zone A or whatever. We also obviously have RTSP streaming for not well integrated VMSs. We have an API. So you know, for us, it's a camera. Not as many VMSs are integrated often because it's a more expensive product, so they've never seen it. But hey, we put it up on our site and you can get access to it and they'll integrate it. But of course, OnVIF is simple.
Did that answer your question, boss? What was your?
I can't believe we're out of questions, not with this group. Wow. Well, thanks to all the panelists. I mean, this has been great. I enjoyed it because this is always an interesting topic for me because it's hard to keep up with the technology changes over time. So I was excited to be able to be part of this. And thank you all for all the great information. Anybody has any interest in any of this, please feel free to contact any of them outside of this venue, but or even post this presentation. So everybody be happy to talk. So nothing else.
And I think an important slide that you had, your nice graphic that came up, is showing if it's a critical infrastructure, right, is having a layered approach like we heard yesterday, and having multiple technologies, so you don't have a single point of failure. You know, you got radar, you got LIDAR, you have a camera to video verification, you know, having all of them together so you don't have any weak spots is really important.
Well, I know one of the big challenges as somebody who's tried to figure out how to make all this stuff work together has been, okay, well, with perimeter technologies, especially outdoor technologies, how do you do it and maintain and manage the overload potential that you may get out of those for false, nuisance alarms, all those kinds of false detection ranges. One of the things that was really intriguing to me about all of these technologies is they do help us do a lot more in managing those nuisance and false alarm detection considerations than maybe technologies we've used in the past. So as I walked through and did my research on these products, it was all kind of interesting and kind of looking forward to all of this discussion today. So thanks everybody for the time. I hope we were able to answer all your questions. Fortunately, all I had to do was sit here and listen to most of it. So, but enjoy the rest of the day. Thank you very much.
Thank you.